Good morning, this is GIV. DucatiMonster600cc model year 2000. We have to restore the engine. Something falling inside the intake system, so we have to mount the head cylinders to check if something is inside in the combustion chamber. Tapping a bit. There are three different sizes, so trace them. There is already a trace here in the sprocket, so we did as well on the belt, and this way even better. There should be a belt tensioner pulley here inside, so we have to unmount this cover. This is the steady axle, and releasing this screw, this should rotate, and this pulley should free the belt so we can extract it. So now trying pulling out the belt from the gear. Remember, this is the reference which has to cope with this. Tie the belt in order not to lose the contacts in the hidden gear. The key of 15, which copes with this nut, doesn't get into the space we have allowed. Here is the worst case. It is a gap of 9 millimeters. Better losing a key than the nut of the head cylinder. So now the head is free and we can move it. Here it is. And here is the problem. This element floated into the combustion chamber. We have to extract it from the intake valve. The back cam of the camshaft is tightening the system, and we can see the valve is a little bit damaged. Necessary here to unmount the intake valve. Open the camshaft cover. So we will proceed moving the camshaft, but first we have to protect the sprocket. But even this, it's not possible, so there is a problem with the X of the valve. As we can see, there is a certain gap here between the rocker arm and the tip of the valve, but the valve is steady. So there should be a bending of the valve. So we will try drilling the nut. This is the valve, this is the seat, and the nut in this position. By drilling this way, we try to take some material off the nut in order to let it slip in but it does make a reaction of the seat, and this reaction increases the friction while we push on the other side. The more we drill, the higher the friction. The more we push, the higher the friction. So we decided to stop drilling and changing as well the direction of pushing. And we made it. Valves and seats for sure have to be changed, but now there is another problem, because the valves are free for a limited extension of the timing. So maybe the intake valve is bent still in an upper position, and we can't go on opening more. Now we have to trace some reference about the timing. When the exhaust valve closes while the intake is opening, we are at the TDC opposite of combustion, and we can understand that the sprocket of the camshaft goes anti-clockwise, and again this mark aligned with this indicates the TDC opposite of combustion. Now opening in order to dismantle the camshaft. Okay. So now we can follow the timing. Now in order to trace the TDC, we have to register the lift of the intake valve at the TDC. The instrument is set at 0 now, and try to move to the TDC mark. We have 1.8. Repeat again. Now 2.25. Then again 2.20 something, 25. 3 millimeters, but now I tried to align in a better way the two marks. This mark with this in the head cylinder. So this is the sprocket and this is the head cylinder. So the alignment has to be perfect. So let's go on with this 3.70 now, 3.35, 3.7. So there is a problem of reference at the TDC, because this is not possible to lock it in the position when the two marks are aligned. So after many trials, in order to get used to the system, to the measurement system, the highest repeatability experiment gives back a lift of 4 millimeters, almost 3.80, 3.90, corresponding to an alignment of the two marks where the camshaft preload springs don't give back instability. So it's a position very easy to leave the system in.